Hey class, Mr. Hanji here. For today's lesson, we are going to take a look at section 9.3, which is going to look at properties of rectangles, rhombuses, and squares. So today's lesson, we're going to continue our look at quadrilaterals, four-sided shapes. 9.1 and 9.2 dealt with parallelograms, where they have opposite sides are parallel and opposite sides and angles are congruent and diagonals bisect each other. So we talked about parallelograms. Today we're going to talk about three different types of quadrilaterals. So rectangles, rhombuses, and squares. Now, for today's lesson, you have one learning goal. And our learning goal for today is that you will be able to use the properties of rectangles, rhombuses, and squares to find various side lengths and angle measures, and to determine if a quadrilateral is a rectangle, rhombus, or square. So, let us begin. First, let's take a look at rectangles. For a rectangle is a quadrilateral with four right angles, and the figure shows a rectangle ABCD. Now, that is the most basic definition of a rectangle. That is a quadrilateral with four right angles. So as long as we know a shape has four right angles, it can at least minimally be classified as a rectangle. Now, things that we know about rectangles. Opposite sides are congruent. So AB is the same size as DC, and AD is the same size as BC. That's something you should know previously about rectangles, that opposite sides are the same length. Now, it's not a property necessarily right off the bat that we're going to utilize, but it's just something to note. All right, so our first property of rectangles that we're going to utilize for this lesson on 9.3 is that if a quadrilateral is a rectangle, then it is a parallelogram. So all of those properties that we talked about parallelograms applies to rectangles as well, meaning that opposite sides are congruent, opposite angles are congruent, consecutive angles add up to be 90 degrees, and that the diagonals bisect each other. So those four things are still in play for a rectangle. Now, the other one is if a parallelogram is a rectangle, then its diagonals are congruent. Now, what we talked about with parallelograms is that their diagonals bisect each other, so those individual parts were congruent in the diagonals. For rectangles, we're saying that the diagonals are congruent to each other. So if I drew a diagonal from A to C or D to B, these would be the same length, which meant if they bisect each other, all these little parts, those little segments inside that we saw from 9.1, 9.2 would be congruent to each other as well. So the main thing we've added is that the diagonals are congruent. So with that said, let's move into example 1 that's going to deal with rectangles. Alrighty. So example 1 is going to have us find each measure. So for A, they tell us that AD is 7.5 centimeters and DC is 10 centimeters, and they want us to find the length of DB. So they tell us AD is 7.5. They also tell us that DC is 10. And what they want us to find is the length of DB. So they want us to find that length right there. Now, a few things to know. A, we already know that all the angles are 90 degrees, so opposite angles are congruent, and consecutive angles add up to be 180. So that's all taken care of. Now, we need to figure out with the diagonal what that measure is. A few things. Remember, with side lengths in a rectangle, opposite sides are congruent. So that's 10, and BC is also 7.5. So I'm going to move it back over even though it's going to cover it up. So knowing that, okay, we're going to use that information to figure out BD. So you're asking yourself, okay, well, how do we go about doing that? Well, if you notice, okay, if I use the side AD along with BD and with the side AB, those three sides form a triangle. And in fact, because we know all the angles in a rectangle are 90 degrees, it forms a right triangle. And the thing we know about right triangles is that we can use the Pythagorean theorem. So we're going to use the Pythagorean theorem to figure out what DB is. And if you notice, DB is our hypotenuse because it's the side opposite of the right angle. So anytime you're dealing with diagonals, know that the diagonal is always the hypotenuse. Any of the side lengths are considered your legs. So Pythagorean theorem is going to state that AD squared plus AB squared equals DB squared. So I'm going to go ahead and write that out, that AB squared plus AD squared is going to equal DB squared. So we're going to use that to go through and figure out what DB is, and that is our answer. So I know that AD is 7.5, so we're going to have 7.5 squared plus, I know AB is 10, so plus 10 squared equals, and we want to figure out what DB is. So that's going to be equals DB squared. So then all we have to do is just go through and solve. I highly recommend utilizing a calculator because we're using decimals here, and squaring decimals can get a little confusing. So if we do 7.5 to the power of 2, we end up with 56.25. If we do 10 squared, we end up with 100. So I now have 56.25 plus 100 equals DB squared. From here, we're going to add these two numbers together. So 100 plus 56.25, and we're going to end up with 156.25. And that is going to equal DB squared. Now, thinking back to the last time we talked about the Pythagorean theorem, or when you have talked about it in previous math classes, at this point, to go through and solve, all we need to do is take the square root of both sides. So we then take the square root of both sides. So we end up with DB on the right. And then on the left, if we do second x to the power of 2 to give us square root, we are going to end up with, well, we take the square root of 156.25, and we end up with 12.5. And that is our answer. So the length of DB is 12.5 centimeters. And that is how we go through and do these problems. So with that said, I would find it helpful to go through and do one more just to give you another one to reference. So if we look at B, we're going to follow the same idea that we just did with A in using the Pythagorean theorem to solve this. So if we look at B, and I'm going to go ahead and move this up, they tell us that AB is 17 centimeters. So this is 17 centimeters. They tell us that BC is 12.75. So this is 12.75. And because I don't have enough room to really put that on my screen for this, I'm just going to put the 12.75 here as well, because we know the opposite sides are congruent. So I know that DC is also 17. Now, this one asks me to figure out what AC plus BD is. So AC and BD are the two diagonals. So the goal for this one is to figure out the length of one of the diagonals and then take that number and add it to itself, and that will give you your answer. Now, if it were to ask you to subtract the two diagonals, okay, if they are the same measure and you're subtracting them, it's just going to end up being 0. So if we're doing AC plus BD, it doesn't matter which one we go with in terms of solving. Let's go ahead and let's figure out AC just to kind of give us a different one to reference. So if we're going to go through and figure out what AC is, okay, I'm also going to use the sides of AB and DC for my triangle. So I formed my triangle. I know that AD is 12.75, DC is 17, and we need to figure out what AC is. So I'm going to go ahead and move this up. Now, for this problem, again, we're going to use the Pythagorean theorem. AC, just like with part A, is considered my hypotenuse because it's the longer side, or the side opposite the right angle. So if I'm setting up my Pythagorean theorem, it's going to be AD squared plus DC squared equals AC squared. So we're going to have AD squared plus DC squared equals AC squared. So we're going to use that as our guiding point to then fill in the numbers. Now, I know that AD is 12.75, so we're going to have 12.75 squared plus, I know that DC is 17, so plus 17 squared equals AC squared, and I don't know what AC is, so we're just going to leave that as AC squared. And then from here, you're just going to go through and solve for AC. So we're going to square the 12.75 and 17, add them together, and then take the square root. So if we do 12.75 squared, we end up with, and I'm going to write this whole decimal out, 162.5625. Then if we do 17 squared, we're going to end up with 289. That's going to be plus 289. And that equals AC squared. All right, so next we're going to do 289 plus 162.5625. And we are going to end up with 451.5625. I know the decimal is fun, but we need to keep it. So we got 451.5625, and that's going to equal AC squared. Now that I've added it together and I have the square on the other side, to get rid of the square, we're going to take the square root of both sides. So I end up with AC, and then if I take the square root, let me cancel that out, if I take the square root of 451.5625, we get 21.25. And that is our answer for part B and what the length of AC is. Now, what they wanted us to ultimately find is what AC plus BD is. I now know that AC is 21.25, and what we talk about in terms of properties is that the diagonals are congruent to each other. So that means AC is the same measure as BD. So I know that AC equals BD. And if I want to figure out what AC plus BD is for right here, it means I'm going to take 21.25 and do 21, or add it to 21.25. So if I add both of those together, 21.25 plus 21.25, we end up with 42.5 for the value of AC plus BD. And that is our final answer for part B. So if it asks you to go through and add two diagonals together, figure out the length of one of the diagonals. That's the same measure as the other, so you just add them together. If it's going to ask you to subtract two diagonals, if this was AC minus BD, if they are the same measure, something minus itself equals 0. Alright, so that is for part B, and I know that took a lot of our time, parts A and B, but I wanted to run through with the Pythagorean theorem just to give you guys that reference. Alright, now for part C, okay, we are going to be dealing with angle measures here, and we need to go through and figure out the measure of angles 1 through 5 based off of our diagram here on the right, and they only tell me that this angle is 61 degrees. Alright, so a few things to note. Okay, opposite sides are parallel, so if I have two parallel lines cut by a transversal, okay, remember alternate interior angles is going to play a key role, and also remember that all the angles in a rectangle are 90 degrees. So this diagonal is going to cut these two angles into two different parts. So if this was originally 90 degrees, and I know this part is 61, to figure out 4, all we need to do is take 90, because this should be a 90 degree angle. So it needs to be 61 plus whatever 4 is, equals 90. So we're going to do 90 minus 61. And we get 29. So I now know that the measure of angle 4 is 29 degrees. Alright, if we go from there, let's go ahead and take a look at angle 1, since it comes before 2. For angle 1, if I have two parallel lines cut by a transversal, angles 1 and 4 are on alternate sides of the transversal, and they're in between the parallel lines, so these two are alternate interior angles, which means that they are congruent to each other. So if angle 4 is 29, that means angle 1 is also 29 degrees. Now, applying that same idea, if I know this is 61 degrees, that means I know angle 2 is also 61 degrees. Now, from there, we need to be able to figure out what angle 3 or 5 is. To do that, okay, if we just focus on the fact that if I were to take out, say, the bottom right half, okay, with angles 1, 5, and 61 degrees, okay, that forms a triangle. Knowing for a triangle that they all add up to be 180 degrees, if I know that I have 61 degrees and 29 degrees, to find the measure of angle 5, all I have to do is 180 minus 61 minus 29, and that would give us our answer. The other thing, if I know this is a rectangle, Okay, in a rectangle, we know that the corners are 90 degrees. Okay, let's assume that they told us this was a rectangle. Okay, if I knew it was a rectangle, that means angle 5 is a right angle, so it's 90 degrees. And opposite angles are congruent, and angle 3 is also 90 degrees. And that is how you do part C. So there's a couple different ways you can run through it, whether triangle angle sum theorem, using alternate interior angles, consecutive angles, and whatnot. And also the fact that rectangles angles are right angles. All right, so that is it for rectangles. One quick note on squares before we move on to rhombuses is that a square is a quadrilateral with 4 sides congruent and 4 right angles. So key thing here for a square, because we're going to talk about different ones. Okay, a square is the most restrictive in the fact that all 4 angles have to be 90 degrees and that all 4 sides have to be equal to each other. So it's not just that all 4 sides are congruent, but it's also that all the angles are 90 degrees. And the reason why we specify that they have to be 90 degrees is because when we get into talking about rhombuses, okay, a rhombus is going to be a quadrilateral that has 4 sides. And let me get this lined up here. There we go. Whereas a rhombus is a quadrilateral with 4 congruent sides. So if we just said a square has all 4 sides are congruent, that could also imply a rhombus. So a square is very restrictive in that it's all 4 sides are congruent and all 4 angles are 90 degrees. Now, let's talk about properties of rhombuses. So JKLM is a visual of what a rhombus can look like. So we just know that all 4 sides are congruent. Now, properties of rhombuses. If a quadrilateral is a rhombus, then it is a parallelogram, meaning opposite sides are parallel, meaning opposite sides are congruent, opposite angles are congruent, consecutive angles are going to add up to be 180, and diagonals bisect each other. Now, for the other ones, if a parallelogram is a rhombus, then its diagonals are perpendicular, meaning the diagonals are going to cross at 90 degrees. Okay. Next, if a parallelogram is a rhombus, then the diagonal bisects a pair of opposite angles, meaning it's going to cut the angles in half. So if we start with angle V, it's going to cut this one in half. So if this was originally 40 degrees, this part is 20, this part is 20. Same thing for Y, W, and X. It's going to cut those angles in half. All right, now for example 2, for part A, they want us to use rhombus VWXY to find each measure. So if we look at this, we've got 4 different expressions, and we need to go through and find the measure for each of those. But before we can do that, we need to figure out what M and N equal. So let's go ahead and start with M. For M, I know that this is 6M minus 12, and that's for the side length VW. And the other thing I know is that this is 4M plus 4, and that is for WX. So those are for side lengths. What do we know about the side lengths in a rhombus? Okay, basic description of a rhombus is that all 4 sides are congruent. So that means that this side is congruent to this side. So if they are congruent to each other, that means they are equal to each other. So we can take both of these expressions, set them equal to each other to solve for M. So we're going to have 6M minus 12 equal 4M plus 4. We're going to go through and solve for m. So we're going to move the 4m to the left. 6 minus 4 is going to give me 2m minus 12 equals 4. We need to move the 12 to the other side, so that means we need to add it. So if we add 12 to the right, 12 plus 4 is going to give me 16. So I now have 2m equals 16. To solve for m, we just have to divide by 2. So 16 divided by 2 is going to give me m to equal 8. So I now have m equals 8, and that's just going to be our starting point for right now. We're going to use that value to figure out what VW and WX are. So let's go ahead and figure out the side lengths. One thing that we know is, again, all 4 sides in a rhombus are congruent. So all I really need to do is just figure out what one measure is, and then I can apply that to the other. So I know that VW is equal to WX. So I just need to choose one of these to plug it into. Let's go with the 4m plus 4. So if we do 4 times 8 plus 4, if we do 4 times 8 plus 4, we end up with 36. So that means VW and WX is going to equal 36 units long. So I have successfully gone through and found the length of different side lengths. The next thing we need to do is figure out what n equals to figure out some angle measures. Alright, now to figure this out, a couple things. N is involved with 2 angles, and that's WVZ, so this angle right here, and also this angle right here for WZX. Now, key thing here is that the diagonals are perpendicular. So that means this is 90 degrees, this is 90 degrees, this is 90 degrees, and that is 90 degrees. So all 4 of those are 90. So if I know that all 4 of those are 90, that means I know this 3n squared minus 0.75 is 90 degrees. Now, knowing that is going to help us. Now, I don't know anything about this angle measure other than it's equal to this. Now, there's nothing else told to us about this, so I cannot set this equal to something. You cannot set this equal to this and figure out what n is. Instead, we're going to use the fact that we know this is 90 degrees to solve for n. So we're going to take this and set it equal to 90 to figure out n, and then we can plug it in. So whenever you get to the problems that are dealing with a rhombus and they give you an expression for one of the angles that is inside the shape, like this, and it's at where the diagonals cross, know that you're going to set this equal to 90. Anytime that you get to these problems on the homework, okay, if it's pointing to an angle where the diagonals cross, these equal 90, just right away set it equal to 90 and solve for the variable. Alright, so we have 3n squared minus 0.75 equals 90. From here, we're just going to go through and solve. So add the 0.75, divide by 3, and then take the square root. So if we add 0.75, we're going to end up with 3n squared equals 90.75. We now need to divide 3, so we're going to do 90.75 divided by 3, and we end up with 30.25. So we get n squared equals 30.25. from here, to get rid of the square, we're going to take the square root of both sides. So if we take the square root of both sides, we do second x squared, 30.25. We end up with 5.5. So that means n is going to equal 5.5. And if I want to know what the measure of angle WVZ is, so that's this angle right here that involves the 9n plus 4, we're just going to take 5.5 and plug it in for n. So we're going to have 9 times 5.5 plus 4. We use our handy-dandy calculator. 9 times 5.5 plus 4. We end up with 53.5. So the measure of angle WVZ is going to be 53.5 degrees. And again, I know that this angle measure here for the 3n squared minus 0.75 is 90 degrees because diagonals are perpendicular. Alright, so with that said, there's just two last parts to talk about, and then we'll wrap up our notes for today. So parts B and C are going to have us go through and use diagrams and then properties of rhombuses, to go through and figure out what all these angle measures are. So just focus on one at a time. If we look at B, so we need to figure out measures of 1 through 5, and they tell us that this angle right here is 20 degrees. Now, based off of the properties of rhombuses that is listed up above, and I'll read it again. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Because we stated that a rhombus is also a parallelogram, that means angles 1 and 4 are congruent, and that this angle is also congruent to this angle. So if the diagonal is bisecting this right here, if I know this is 20, then I know 5 is also 20 degrees. Okay, because the diagonal is going to bisect it, so this would be equal to this. They are congruent to each other because they're cut in half. And if I know that this whole thing here is 40, because in a parallelogram, opposite angles are congruent. If this is 40, that means both of these add up to be 40. And if it's bisected, that means these two are the same. So 40 divided by 2 is 20. So 20 and 20 for angles 2 and 3. Now, to figure out angle 1 and 4, again, just focus on the fact that we have a triangle here. So if I know that angle 2 is 20 degrees, if I have two 20 degrees, 20 plus 20 is 40. If I do 180 minus 40, 180 minus 40 is going to give us 140 for angle 1. And remember, opposite angles are congruent, so 1 and 4 are also 140. And that's how you do part B. Now, for part C, a little bit different because the angle that we have been told is in a different spot. So they tell us that this is 84 degrees, and again, we need to go through and figure out measures of angles 1 through 5. First of all, 84, opposite angles are congruent, so if this is 84 degrees, then I know that angle 4 is also 84 degrees. So that is our starting point. So I now know that two angles are 84. The question becomes, how do we figure out the other ones? So there's a few ways that we can do this. One way that I suggest that we focus on, again, is we just focus on one of the triangles. So if I tell you to cover up, if we focus on this triangle right here, in a rhombus, we know that all four sides are congruent. So if I know that, and if I just focus on one of the triangles, okay, based off of this, I know that I have two sides congruent, and if I have two sides congruent, that means I have an isosceles triangle. And if I have an isosceles triangle, that means this angle is congruent to that angle. So to figure out the measure of angle 1 and angle 2, we're going to take 180 degrees subtracted by 84. That is going to give us 96. So that means these two angles add up to be 96. If they have to be equal, they have to be the same measure. To figure that out, we're just going to divide them by 2. So we're going to take 96 divided by 2, and that's going to give us 48. This means I know the measure of angle 1 is 48, measure of angle 2 is 48, and then because I know the diagonal bisects these angles, that means I know 1 and 5 are congruent, so they're both 48, and I know that angle 2 and 3, that was bisected originally, it means they're both 48. And that is how we do part C. So that is really the gist of our notes for today on section 9.3 on properties of rectangles, rhombuses, and squares. Just to kind of quickly summarize, we've now talked about parallelograms, rectangles, squares, and rhombuses. What this diagram here talks about is that these are all quadrilaterals, so that's the larger idea. Quadrilaterals have four sides. The next level is a parallelogram, where opposite sides are parallel to each other, which would be the case for a rectangle, square, and rhombus. Now, for a rectangle, we know it is a four-sided shape, opposite sides are parallel, and that its angles are 90 degrees. Then, for a rhombus, we know it's a four-sided shape. It's a parallelogram, meaning opposite sides are parallel. And the definition of a rhombus tells us that all four sides are congruent. So, rectangle, all four angles are 90 degrees. Rhombus, all four sides are congruent. So rectangle has 90-degree angles. Rhombus has all four sides congruent. So if we get to a square, square combines both of those ideas. That it's a four-sided shape, opposite sides are parallel, all four angles are 90 degrees, just like a square, or like a rectangle, and all four sides are congruent like a rhombus. So, with that said, that is it for our notes on section 9.3, properties of rectangles, rhombuses, and squares. And we have just added 3 more to our knowledge. So, with that said, that is it for today. Thank you guys for listening. If you have any questions, as always, let me know via email or next time you see me. Be sure to use the completed notes as a reference, and I hope you guys have a great day, and I'll talk to you later. All right, bye.